Hi everybody. I am going to discuss with you analog electronics lab. Here I will start from first first experiment. So this is experiment number first, characterization of characteristic of PN junction and zener diode. Here aim of the project this experiment is to know the IV characteristic of PN junction diode and a special type of diode that is called as zener diode. So requirement of this experiment is PN junction diode, zener diode, resistance 220 ohm. The resistance used to protect the diode. Actually, if you supply directly connect diode in reverse bias or forward bias, there is a lot of large drop across the diode and diode can break. So to protect the diode we are using generally resistance. Another component is another device what you want to what you use in this experiment is digital multimeter, and another device which you are going to use in the experiment is a regulated power supply. You can generate your regulated power supply. We have given that in project based lab based project also. So here you can see the DC regulated power supply which is available in our lab, and we are using 0 to 30 volt and which can supply maximum current of 2 milliampere. Another thing is breadboard. Breadboard is a device which is provide you vertical chart and horizontal chart, and where you can mount your all the equipment, like zener diode, resistor, digital multimeter. And then finally you need connecting wires. Many connecting wires you need, that you can use that for the connection of different component in the different component on the breadboard. So this is the circuit diagram of your circuit. So here you can see this is your power supply. This is your power supply, this is resistance, and this is ammeter, and this is a diode. Diode, this is a diode anode, and this is a diode cathode, and this is the voltmeter which you connect across the diode. This circuit is for forward bias. Why forward bias? Because here this variable variable in the sense of 0 to 1, 2 or 3. Here you can see positive terminal of the battery is connected to anode and negative terminal of the battery is connected to the cathode. Because of this reason this diode said to be connected in forward bias. So this is the circuit diagram for forward bias, and this is the circuit diagram for reverse bias. This is the circuit diagram for the reverse bias. Here you connect 0 to 30 volt again. And what is the difference between previous circuit and this circuit? The rating of ammeter is changed now, that is varying, that is in the micro ammeter reading, and this voltmeter reading is the same. Another change is you have connected here, we are connected here positive polarity of the battery with cathode of diode, and negative negative terminal of the battery is connected to anode. This is a N region, this is a P region. PN junction is a basically a junction of P and N type material, P and N type material. So P is connected with negative terminal, and N connected with N type of material connected with the positive terminal. So because of this reason, this diode you consider under the reverse bias. In reverse bias direction, current, whatever the you increase the current voltage, current is very small, magnitude of the current is very small. Because of that reason, you are considering here micrometer reading, micro range, microampere range. So second thing means PN junction diode forward characteristic. How you connect? Already these are the procedure. First you connect the circuit, means as we have given in these two figure. Then you can increase the voltage, supply voltage from 0 to 6 volt, 0.6 volt by varying, means that is means lowest step means increment. In what increment you are going to increase your voltage, that is 0.1 volt, and you have to read down the reading of voltmeter and ammeter. So that reading should be recorded in the table. We are going to provide you in the next slide. And here then means here means again you increase the voltage from 0.6 to 0.1, and with some step 0.01 volt, and you will record again the voltage and current, and further you can also increase, and you will see in forward bias current is increasing, and after some time, that is reached by cut-in voltage, your current is your current is increasing but voltage is slightly increasing. That this is the reason you can use your PN junction diode in forward bias, in forward bias as a in forward bias as a voltage regulator also, which can supply a voltage of 0.7 volt roughly. That is the cutting volt of cutting voltage of your silicon diode. And if you consider the here we consider the silicon diode. If you consider the germanium diode, the cut-in voltage is 0.3 volt. So in reverse bias, you means as per your circuit, you have to connect your circuit as per as I suggested you. You connect your diode as per circuit connection, and then you have to vary your voltage from 0 to 30 volt in a step of 2 volt. Again you read the ammeter and voltmeter reading, and your job is done. So this is the table for PN junction diode. Here you can delete this if you want, but it is better to note down how many readings are your how many readings you are going to take. So this is the diode voltage, the voltage across the diode you measured. This is the current that flows in the circuit. This is not a this circuit connected in series, that's why IED is same for all the circuit. And again you have to record the VD voltage and ID voltage, and you should plot these voltage later. Now come to the zener diode. One thing I want to tell you, you can use your zener diode. Zener diode is a special purpose diode. Zener diode is a special purpose diode. You can use this as a normal diode as regulator, but when it is a forward direction, it will pass the current, and it is a normal diode. When you are connecting in reverse bias, it is a special type of diode. If you see the if you perform the experiment, PN junction diode break at larger voltage, but your zener diode will break in reverse bias at a particular voltage which was decided by your manufacturer, and that breakdown depend on the tunneling of carrier, avalanche breakdown, all these things, and that has a particular value. After that, your current is behaving as your diode behaves in forward direction. So this is a connection. Here again you provide the positive polarity connected with the anode, and this negative terminal connected to the cathode. So this circuit is this is a forward bias connection of your zener diode. In this in this circuit, your diode behave as normal diode. In this circuit gives you a normal characteristic of diode. There is no difference between the diode means experiment you perform just before and just now. There is no difference, but difference will come here when you connect your positive polarity of your diode with cathode, and when your negative polarity is connected to the anode, the diode is now in reverse bias. When you increase the bias voltage here up to certain voltage, then you will get here here you will get after breakdown, the current through this circuit is constant. Current is varying but voltage is constant. That is the beauty of your zener diode. Now this is the graph, this is the table which you have to fill. This is a forward zener diode in forward bias case, zener diode in forward bias case. Here you have to note down the voltage and current. You will plot this plot a graph between voltage and current. And zener diode in reverse bias, here real behavior of zener diode you can find. If you vary the voltage after some time, suppose that 6.5 volt is the zener breakdown, before that you will get the you will get variation in the voltage and variation in the current also. But after breakdown you will get the variation in the current only and variation in the voltage nearly constant. That is called as from where your zener diode we having a constant voltage, maintaining a constant voltage across the junction and increasing the current, that point called as breakdown voltage. So this is the expected graph. From this graph you can calculate static resistance and dynamic resistance. If you consider a point here, then this point will give you the static resistance. Simply you can take a voltage V and divide that voltage by I current here, then that give you on resistance R and static resistance. If you take a slope of this exponential curve, then you will get a dynamic resistance dV upon di, slope of this. Another point you can calculate of this from this graph, that is your that is your cut-in voltage. Take a take exponential region. From there draw a straight line to the voltage axis where that cut, that is your that is your cut-in voltage or on voltage. Here, as I told you, this is the characteristic of your zener diode. This is the characteristic of your zener diode. In this case, you can calculate the breakdown voltage. You can draw a straight line. From here to here, where it cuts negative axis of your voltage. That point is called as breakdown voltage. That is called as breakdown voltage or zener voltage also it is called as. And cut-in voltage here is the same. So there is a difference between cut-in voltage and zener there is a difference between zener diode and simple diode. Here you can see there is a small breakdown. This voltage is not very less here. This voltage is going to 20-30 like that, but this voltage for your zener diode what we are giving in your experiment, that is 6.5 like that. So this is the difference. This is the special doped diode, special type of diode. The zener diode generally used for voltage regulation. I hope this video will help you for conducting your experiment in the laboratory of our department. So have a nice day. Thank you.